Hi students, now that we have already learned the function of derivative as a gradient of a function, let's see how we can actually apply it to a very important concept here, which is called the stationary point. Stationary point is essentially the point where the gradient is zero, or rather dy dx is zero. Okay, so I hope you remember from EMath, you know that this is a positive gradient. Okay, just remember that this is m positive, and after which gradient is zero, it's when m is 0, and this would be when m is negative. Okay, remember that. Now, what you will need to know next is essentially when you are drawing tangent to the curve there, for example, if you want to draw the tangent to this point here, what you do is you just take a ruler, right? You remember in EMath, elementary mathematics, what you need to do is actually just align it so that it just touches it, and then you just measure the gradient there. Okay, so why is gradient 0 so special as we trace along a continuous curve? Actually, it gives us a very interesting idea of how the curve actually behaves, and with this interesting idea, we can actually apply it to a multitude of application in real life example, which we will explore in the later part of the chapter. So I'm just going to illustrate this using a Desmos curve, very simple one. Let's say I'm just going to draw something similar, at least something similar with the ones that you see there. So let's say cube plus 3x squared, 3x squared. There you go. Okay, great. So something similar like that. Now, what I need to pay attention is actually this gradient value here. So what I did was actually just okay, maybe I just switch off the label here. Okay, great. Okay, so this part here, as you know that this part here, this is a negative gradient. Now this is the gradient, the actual gradient. If you were to just measure, take rise over run, that would be the gradient at that point, which is not surprising. It should be a negative value because this is a negative slanting downward. So if you go to the other side here, this is actually a positive gradient, right? So the question now is, when is a zero gradient, there you go, when it's a zero gradient, what happens, right? So then when it's a zero gradient here, what happens? Okay, now you sort of get the idea, right? Where the zero gradient happens. The zero gradient happens is when it's parallel, the tangent is actually parallel to the x-axis. So what we're gonna get is actually this thing here, and these few points here. Okay, so we have 3 stationary points here. Just take note, this is point number 1, point number 2. So let's say this is, maybe I just name this as x1, x2, x3, right? So this is x1, this is x2, this is x3. Okay, so what we're going to do is essentially we're going to put this as m equals to 0, dy dx equals to 0. Okay, this is dy dx equals to 0, this is dy dx equals to 0, dy dx equals to 0. Okay, so this case here, now what you realize is when dy dx equals to 0, it sort of have this point here, this valley, like this point. So it's not surprising, this is what we call the minimum point. Okay, because it is the minimum point. Like it is the minimum, right? Like you could see that it's going down to a minimum. So this is what we call minimum point. Minimum point. Okay, and this is what we call the maximum point. Okay, maximum point. And this is what this is also minimum. Okay, now together these are called the turning points. Okay, but take note, not all stationary points are turning points. Okay, so these are turning points. This is what we call turning points. So just take note, these are turning points, also known as turning points. Okay, so max and min are turning points. Okay, so just take note. Let me just type that down quickly. So I have to be very clear here because I need to keep regurgitating this, which is they are called turning points, but not all points are turning points, because you also have a case where this is what we call the point of inflection, where the gradient here is an S curve, but is actually flat here. Now, some point of inflections are not stationary points either, but in your syllabus, essentially, you have stationary point of inflection where dy dx is 0 and d square y dx square is 0, this part here. So let me just illustrate this to you like that. Okay, so say if you have a x cube, okay, let's just put the this case here like 5. Okay, there you go. So this part here, you know that this will be a gradient 0, as you could see, and just go all the way up. But not all, though not all what do you call it, not all point of inflection like that is actually point of inflection has a gradient of 0 here. Okay, just take note. Some will actually slant it up. So let me see whether I could find something here. So this is an example of the S-curve where this is not a stationary point of inflection, where the gradient here is not 0 at all. Okay, so this is actually a gradient 2. So just take note that yeah, not all point of inflection has a stationary value. Not all point of inflection is a stationary point of inflection. Okay, only when the gradient is actually 0 on this side in the middle here, which will constitute a stationary point of inflection. Okay, so let me just type that out. So this is what we call point of inflection. Okay, point of inflection. So one is a negative slanting one and the other one is a positive. So let me just continue writing this stuff here. Not all stationary points, all turning points are stationary points, but not all stationary points are turning points. Okay, point of inflection is not a turning point. Point of inflection in stationary point of inflection, stationary point of inflection is a stationary point, but not a turning point. Okay, great. Okay, so just take note of that. Okay, so I just write that down. It's a stationary point, but not a turning point. But also take note that not all point of inflection is a stationary point. Okay, so maybe it's quite confusing, I know, but I will just stress on these few points. So not all point of inflection is a stationary point. Okay, so inflection is basically an S-curve. So just now I gave you an example, which is the example where it doesn't have a 0 at the flat end there. Okay, so subsequently, this is the basis, and this is the main concept, the framework for stationary point. We will look at how we actually find the stationary point by using the first derivative test and also the second derivative test. Okay, so you need to know how to use these two tests here because it's part of a syllabus. Yeah, see you in the next video.